Friends, it's Ian Khan, the Futurist, here at the Humanoid Summit in the Bay Area. I've got with me Kamel Saidi with NIST, and Kamel can tell us a little bit about standards and standardization of all these amazing things we're talking about here at the summit, which is robotics, humanoids, AI, data, 100 different things. Kamel, welcome to the Futurist podcast and the video series.
Thank you for having me.
I've had a great amount of conversations here,
I'm
learning so much. So it's great to be here.
Okay.
And I'm sure you've seen many things here which are nice. Tell us about what do you do in your role, first of all, that brings you to this conference, and then what's your mission here to find out and see and share? What brings you to this event?
Yeah, so this is my second time at the Humanoid Summit, but I lead a program on robotics standards at NIST, where we have 9 different projects looking at all aspects of robotics. We focus on manufacturing, emergency response, autonomous vehicles, and a few other things. We've done construction as well as assistive technology and so on. But in all of those things, we look at how to understand the performance of these systems and what metrics do you use, what tests you have to run, and then those eventually lead to standards. Right. So our role really is not to set the standards, even though we are the National Institute of Standards and Technology. We don't set many standards. We help industry develop voluntary standards.
Okay.
But we have the resources, knowledge, experience to develop measurement science, which means ways of measuring things, techniques, algorithms, data sets, instruments, etc. So, for instance, back in the 1980s, we were looking at robots, industrial robots, and trying to understand their performance. And I wasn't there at the time, that was before my time, but at the time we realized that there was no good way of measuring what an industrial robot is really doing, like how is it moving in space, in 3D. And so we developed an instrument specifically for that, plus other things. And then we licensed it out, and now that's a commercial instrument that's used, it's called a laser tracker, that's used in industries all over, and it's made by many different companies, big companies you've probably heard of.
Okay.
So our role is to do things like that. Not always develop technologies, but develop the measurement science.
Incredible.
And so for our program, we're looking at developing measurement science to understand things like robot arms. How do you measure their accuracy, repeatability? There are standards out there, but we're looking to improve them as well. Mobile robots, mobile manipulators. And in all of those things, we're also always looking to see how people can adopt them more easily.
Of course.
And so in robotics, we're heavily focused on the small, when we talk about manufacturing, we're heavily focused on the small and medium manufacturers, because in the US at least, and it's similar in other countries, they make up the majority of the manufacturers. It's not the big, the GMs and so on that are the majority. The majority are the small and medium ones. And if they are not taking advantage of all this automation and robotics, then we're not moving forward. And that's kind of what we're trying to help.
Understood. Now, when you look at an industry growing, like it's at a very small, scale right now, which is the robotics right now, humanoid. It's very small, very small. It's not commercialized, a little bit here and there, there's pockets. Today, there's many things that happen with such things, either they're hyped or they're just blown out of proportion. There's, this is the only thing that we need. Like there's all kinds of things that'll happen, and we don't know what that will be.
Yeah.
But one of the most important things, I think, is safety. How is this technology going to be safe for usage, right? It's like doing a quality check. Is this safe for us or not? Yes, it's going to create a lot of economic wealth and boom, but is it safe or not? It could be dangerous. Is it harmful, which is similar? Is it scalable? Is it, all those different things that you guys measure? What are you doing about robotics? What's on your radar about humanoid robots that you're like, hey, we need to make sure these things, we studied these 10 things, 9 things, 100 things that kind of will potentially create the foundation of the regulatory framework, the operating mechanism, the certifications. What are those points you would be looking at? I have no idea.
Yeah.
Yeah, help me out, please.
Yeah, so NIST is a non-regulatory agency, which means, again, like I said, we don't set standards, regulations,
correct.
policies, and so on. We have done quite a bit in robot safety. So we helped develop the safety standards for collaborative robots, for mobile robots, AGVs, and so on. We were instrumental, we played a big role in those things. But humanoid safety is a bit different. There are standards now in ISO, a new standard that's looking at, they don't call it humanoids, but they call it, I forgot what the name, mobile manipulation, something like that, which essentially is what a humanoid is, right? It's manipulators on some mobile platform, whether it's bipedal or wheeled.
Correct.
It doesn't really matter. But there are definitely safety concerns there. Even though we've been involved in safety, we are for humanoids, we're focused more on the performance aspects. So how well does it do a task? Now, we were involved in the DARPA Robotics Challenge, if you're familiar with that, back in 2013 and 14. We developed the tests for that, and that was humanoids. Since then, we haven't done much in humanoids, but we've been applying a lot of our knowledge to emergency response applications. And in those applications, now we're starting to see a lot more quadrupeds. We haven't seen humanoids yet, even though the DARPA Robotics Challenge was all about humanoids for emergency response. We haven't seen it yet, but we've seen quadrupeds. Now we are seeing, we've seen the videos of all these humanoids doing crazy things, right? Like the old hydraulic atlas, the new electric atlas. So we definitely see the potential in emergency response and many different applications, but we are focused on how to measure performance. So somebody today was saying that people don't show humanoids climbing stairs. Well, we have a test for understanding how a robot, whether it's humanoid, wheeled, quadruped, drone, doesn't really matter for us. It's a test to see how well can you climb stairs. And we can have stairs of different kinds, different angles, materials, debris on the stairs, etc. That's how we're kind of looking at it. At the same time, though, in a lot of these tests that we develop, we have what we call failures or fault conditions. And it's up to the user to determine what a failure or fault condition is. So that can help inform safety, because if the fault is the robot shall not fall, let's say, or the robot shall not come close to a person by more than something, and that occurs, then that will reduce the reliability number that comes out of that test.
Of course,
It doesn't tell you for sure that the robot is safe. You have to do other kinds of testing to ensure that the robot is safe. So that's kind of how we're looking at it, or how we're approaching it, is that we want to understand performance. That can inform safety. We're happy to work on safety as well if that's, it is a big priority, but we've always been traditionally focused on performance, and that's kind of what we're pursuing.
Amazing.
So we're here to kind of understand further understand where the industry is in terms of performance, and to gauge what kinds of tasks. So something I'm going to be announcing tomorrow is we're coming up with a benchmark in collaboration with industry to do a baseline comparison of humanoid robot capabilities. And so I'm here, part of why I'm here is I want to understand from people, companies and so on, what tasks should be in that benchmark. We think that some of the tasks from the DARPA Robotics Challenge should be there, because they're simple tasks like opening doors and going through doorways, picking up something, etc. But we want to get consensus before we develop this benchmark, and that's kind of one of the reasons why I'm here.
Yesterday I was carrying something in my hand. I think it was my kid's stuff, and my both hands were tied, and I had to open a door. I was like, this is parent scenario, like every parent goes through this. Your hands are full, and you still have to open a door, and then I had to make a way to do it. Please incorporate that into your benchmarking. and can the robot operate with its hands full? I don't know. So many interesting things. But thank you for joining us. I love the work that you guys do. It's so important to have this testing and standardization and go towards like stability. At the end, it's like having a stable outcome from the big mass commercialization of whatever is being tested. So it's so fundamental to have a basis for that and say, yep, this was done, but now we're doing it. I think, though, right now, and I'd love to get your opinion on this just as a last comment, is form factor robotics, rapidly changing right now. There's like thousands. There's a hand, just a hand. There's a robot. And I feel they are going to keep on evolving and moving and changing. So you're dealing with a lot of change.
Yeah.
And you have to kind of figure out how do we shrink it and just test kind of what is now a mass movement rather than a fringe robot, right?
Yeah, and also how to get ahead of it, because we don't know what's coming next.
Yeah.
We see a lot of cool things. Which one is going to stay? Which one is going to, disappear? And how do we develop tests for the ones that will stay when we don't know? We can't predict what the future is going to look like. But yes, there are many, many kinds of form factors. So one of the ideas behind the benchmark that I talked about is, in the discussions that we've had with people, is maybe morphology doesn't really matter. Because one of the reasons why people are developing humanoids is because they want them to work in human environments.
Yeah.
Right? And people have said, and this is my opinion as well, is that eventually when we have a lot more of, let's say, manufacturing automated, robots will not look like humanoids. They are humanoids now because the environment is still made for humans.
Yeah, right.
But in certain environments, like in the home, hospitals, and so on, it's always going to be made for humans. Therefore, a humanoid makes sense. Now, whether it's a bipedal balancing humanoid or on wheels, there's all sorts of debates which one will work better in which environment and so on, right? But we have to, at NIST, we have to look ahead and come up with tests that would apply to as many possible form factors as possible. And that's why the benchmark, we're thinking, maybe it doesn't really matter if it's a bipedal or a wheeled. The tests will dictate what the robot will have to do. And if a bipedal humanoid will do better in the test, that's fine.
Yeah, totally.
So,
excellent. Well, thank you so much, Kamel.
Sure.
Best of luck with the conference today, tomorrow, and thank you for joining us.
Yeah.